conversations very developer focused, but this is open for everyone, right? This is open for, as you can see, engineers, managers, geeks, wizards, muggles, everyone. Everyone can join. Let me actually give it another minute before we get started, because I can still see a lot of people coming in. All right, I'm also going to assume that a lot of you are able to see my screen. And I do know this is going out on LinkedIn Live, so welcome everyone. If you're joining us from LinkedIn. All right, I can see the participant count go up. So let's give everybody an opportunity to join in, because I'm sure everything that we are covering today is going to be super useful for the community. Okay, I think we can get started. So before we dive in, let me sort of give you an introduction to who I am. I mean, why am I talking about this? So this is my favorite question in interviews, by the way. What does your resume not tell you about yourself? So what does my resume not tell you? And if you've looked me up on LinkedIn, or you've had some kind of a profile that's been shared with this session, what does my resume not tell you? So I consider my career really to have started with when I was at Yahoo, right? Worked in the media group, then the core platform group, worked on some very interesting problems. Obviously, the scale of problems, obviously, it used to be in the billions, right? So my earliest experience with ML, before even I knew it was ML, was with NLP algorithms, or natural language processing algorithms, right? So you should write code to identify if this piece of content about Shaquille O'Neal is the same as this thread on Yahoo Answers, which is talking about the Shaq Master. Our man obviously acted in a movie and had a music album, and how do you identify that everything was the same piece? And I wrote code and I wrote algorithms to identify it. And I didn't know that I was actually creating the first set of clustering algorithms in machine learning. And that was interesting, because then you write that, and then you get very excited about then using things like Jaccard coefficient and Jarrow-Winkler distance, and all these fancy little libraries. And then you put it on billions and billions of pieces of content and figure out how things work. And that was sort of the power of when I was first exposed to machine learning. Took all of that and essentially went to a startup called Yakit, which was in the logistics tech space, where I got my first exposure to something called supervised learning, right? So you take this data, you apply labels to it, and then throw it at a machine learning algorithm so that it can accurately predict newer things by learning all the supervised things. Spent a lot of long nights, essentially learning that space, driving up the prediction accuracy to 72%. That's actually very good in machine learning terms. Built what was, I think, one of the earliest MLOps pipelines all by myself. I called it TTDR, not a very cool acronym, but MLOps is much cooler. But did one of the earliest MLOps pipelines. And at our peak, we used to do about 2 million unique products a day, which then involved, how do you scale this? How do you make sure you have a response in sub sub-second times and all of those, right? So those are sort of the interesting productionizing aspects of machine learning that brought me to what I'm doing today, which is running the engineering team, head of engineering at Interview Kickstart. Obviously my day job involves building a powerful platform for cohort-based learning. If some of you have been students here and have used UpLevel, you obviously know, you obviously use some part of my work. But since the start of this year, have been completely, I have completely soaked myself into the Gen AI space, chatbots, support enhancements, teaching assistants, ideating, building, and deploying LLM apps across our entire business stack. And also one of the things that I enjoy doing, which is sharing my experiences with all of you, right? So this is what I'm doing today. I'll do more of it because everything that I'm doing and discovering as part of the Gen AI space is new and is worth sharing. So this is something that we'll do. So this series, and obviously 1 hour is not enough to cover this entire piece. So I decided to break it up into 3 parts, right? And today is part 1. So which is the lay of the land, which is what are all the tools and libraries that are out there for building a generative AI app. Part 2 is next week, where we're going to talk about and deep dive into some of these tools and libraries and figure out how to use them, what are the different use cases for it, some sample code, all of that fun stuff. And part 3 is when it all comes together, right? So you understand the lay of the land, you played around with some tools and libraries. Now let's actually build an app, right? I mean, this is what is the fun part. Is let's build something that people can use, and that is sort of how we've structured this 3-part series. So let's get started with part 1. All right. Before we sort of get started with the lay of the land, it's useful to sort of just refresh ourselves on what this world is all about, right? And ever since generative AI has become mainstream, and by the way, it was always there. If you've ever used autocomplete, on Gmail or some of the other platforms, that was a form of generative AI. So we were already exposed to generative AI in some way, shape, or form, but it's just become so mainstream since ChatGPT came out. If you have to now sort of segment that space, we have what is called traditional AI, which is what we all know or what we've all been, exposed to so far in some ways or the others through recommended systems. When you go to Amazon and say, and get that list of items that these are what people bought along with the item that you're looking at. All your Gmail, the spam detection of emails and all of those segmentation there, all the predictive analysis, all of that comes under traditional AI, very rule-based, narrow focus, and it's not built for creativity, right? I mean, it's built for a specific outcome. Usually requires a lot of structured data, and it's generally deterministic, right? I mean, if you give it a certain set of parameters and ask it to do something, it comes up with an output that is usually reliable and the same every single time. On the other side is the generative AI, and generative itself gives you the name, right? It is probabilistic. It generates things. Very, very data driven, right? So it needs tons and tons of data to learn and to sort of augment its neural networks. Has a broad set of applications, right? So when you create a generative AI model, it's not built with a specific application. And we'll talk about some of those nuances in a bit. Obviously, there's a lot of creativity use cases related to it, and it can deal with a whole bunch of data formats, right? It can deal with PDFs, JSON, XML, web page scripts. You just throw it at it, and it's usually good at sort of figuring out and extracting data out of it. Right? I mean, its inference engines are so strong. But that's sort of the fancy way of explaining it, right? I love the way I like to explain it, and when I have to think about how these two words are sort of different is, think of a child, right? A child which a small baby. You show this baby over a period of time. You show them pictures of different animals, right? There's a dog, and this is a cat, and this is an elephant. And then over a period of time, the baby is able to recognize, and you put 3 pictures in front of it and say, point the elephant, and the baby will actually point at the right picture. That is traditional AI, right? That is essentially the baby's the baby's algorithms or the internal processes are learning to recognize patterns, right? Saying this is an elephant and this is a cat and this is a dog. And then the baby grows up and has motor skills with its hands, and you say, draw an elephant for me, and give it a pen and paper, or give it a pencil and paper, and then you see them drawing an elephant, and that is generative AI, right? So now with the patterns that the baby has learned about seeing different animals, you can tell the baby, you can generate a picture or generate a drawing of an elephant, and you don't know what's going to come out of it. And that is the probabilistic nature of generative AI, right? But it's based on all of the learnings of seeing these different pictures of animals. And that's a great analogy in my head, because as much as all of this seems like magic and sorcery in some ways, AI ML is still in its infancy in many ways, right? In terms of everything that it can do, it's developing very rapidly, but it's still in its infancy in terms of what it can do. So that being said, let's get started with the lay of the land and start with the very basic thing, or the very basic tool that we all sort of are already familiar with in some ways, but it's worth talking about, right? Which is the generative models, right? This is the most fundamental tool, or the most fundamental engine of when you're thinking about building generative AI apps. So how are they made? Right? And it's worth sort of diving into it, even though it might not be completely relevant to building apps. It's always good to know how these things are made. So at a very, very high level, right, 100,000-foot level, take a bunch of input, and it could be multimodal, audio, video, text, image. Take a whole bunch of inputs, throw it at some pre-processing layer. And by pre-processing, I mean you do some kind of cleanup of the data, some kind of massaging of the data, remove things like biases out of it, make sure it has enough diversity. All of that good stuff goes into the pre-processing phase. Because ultimately, machine learning models are garbage in, garbage out. It's as good as the quality of the data that you put in. Then you choose, you build your model, right? You train your model, and training your model can involve any different kinds of techniques. And you might have heard of some of these fancy acronyms there, right? You have generative adversarial networks, and variance autoencoders, and autoregressive models, and transformer-based models, which is what GPT is based on, and denoising distribution, denoising distributed probabilistic model, right? So which is a very, very fancy name of saying I can do images, and I can do audio, and I can do video, and that is what a lot of Midjourney and Dolly and all of these things are actually based on. So you choose a method based on what your input is. You choose that method, and then you say, take all this data and let's train the model. Then you have an evaluation step saying, okay, is the model actually producing the right results, right? And how do I go about testing it? There are a whole bunch of ways of testing it. Again, not going to details there, but things like likelihood scores, diversity scores, an actual human playing around with it and saying, okay, this looks pretty good. And obviously, the old machine learning metrics of precision and recall, which measure sort of how well things are being generated, and how precise these generated answers are. And then it's this iterative process, right? You keep doing that until your model gets to a point where you're fairly happy with the output for it. And from there, you deploy it, the whole place where MLOps comes in, and then you generate stuff, right? And this is the fun part, is when it starts to generate stuff. And that generation is, again, other audio, other video, other text, other images from the patterns and from the data that it has already learned, right? So this is from a 100,000-foot view, right? This is how this whole process of creating generative models work. Now, if you have to really look at this, this is typically what any machine learning model building process looks like, right? So it could be traditional AI, it could be generative AI, but there are some nuances here, right? So the nuance here is really in the input. The amount of data required here is massive. And again, if you have to draw an analogy, it's like going to an exam, and you might get 6 or 8 or 10 questions in that exam, but you have to learn an entire subject and an entire textbook to actually go to that exam, right? And that process, that learning of that entire subject or that entire textbook is what that massive amount of data is, right? You have to ingest that data for it to be able to produce data from the text of data that was learned, right? Which is essentially you answering those 8, 10 questions within the exam. So that essentially is one nuance here for generative models is they do require a lot of data. The other nuance is actually what we're going to talk about in a bit, which is the prompts. That triggers the generation process, right? That is essentially the instruction or the thing that you tell the generative model to do, and that triggers the generation process, and that's what creates your output. So these are two important nuances for you to keep in mind when you think about generative models. This is just the amount of data, and obviously the prompt, which we'll be talking about in a little bit. So what's out there? And this is by no means a comprehensive list because this world is actually changing so fast, and there are newer models being made. There are more specific models being made. But I wanted to list out the ones which are, which obviously have a lot of work going on, and obviously have been in the mainstream in terms of its capabilities. So if you want to separate it out by the capability of generative models, obviously we've all played a lot with LLMs, which is the text-based models, right? The language models. And you have GPT, you have Bard, which are the two closed source models. Bard is Google, and then you have Llama and Falcon, which are these very, very powerful open source models. Then on the images side, you have Dolly, Midjourney, Stable Diffusion, and Google's Imagen, which has been around for a while, but it's trying to become more mainstream now. Audio and speech, which is very exciting for us, especially given our teaching credibility. You have Bark and Levin Labs and AudioCraft, Google, universal speech machines. You have the Google USM, and then in video you have these very interesting tools coming out, right? And very interesting models coming out, which is built by Synthesia, DeepBrain, Gaussian, Weed. Why is this important to know? It's important to know this landscape of models, because it is important when you build your apps to choose which model you want to use. And there are certain sort of general rules of thumbs that you apply when choosing models. And then we've sort of used that when we built our own apps. Right? The choice of model directly relates to the problem you're trying to solve. Right? So you could be building a chatbot, so you need a language model. Right? You might want to be doing text summarization, so you don't need something as fancy as GPT 3.5 or 4 or Bard for it, right? You could use something off of Hugging Face. You want to build a model that generates interesting ad copies with images, right? So which means that you don't need one model, you need a language model, and then you need an image model, right? So you need multiple models in that case. Or you want to do short videos for teaching, which again involves using a language model and a video model. So it doesn't mean you have to choose just one model, but identifying the models directly relates to what your problem statement, the kind of problem you're trying to solve. Identify what is important for your product experience, right? These models have different capabilities, right? So something like GPT-4 is exceptionally high quality output, but it is very, very slow. Something like Llama or much smaller models that exist on Hugging Face are very, very fast, right? So they're built for speed. They might not be as rich in terms of the output that they generate, but they're they come back really fast with answers, and sometimes that might be important for your product experience. Or interactivity, right? So you can go back and forth with, there are chat-based models built, right? So you can go back and forth with a model, and that is the experience you want to build. So you want to actually use some of those models. Cost is an important consideration, right? So I'm going to talk about context length when I talk about prompts, but essentially it is the length of the instruction that you send in and the size of the model that you're using, right? So when both of those goes up, your cost goes up, because there's just more processing that's involved in generating whatever output you need to be generated. And finally, consider your own appetite, right? What is your team's capabilities when you're doing something like this? Do you want to just use a hosted model and just connect through APIs, very, very simple, which is what we've done so far? Or you want to take some of these open source models, put it on your own machine or put it on your own server and sort of maintain it from there. And you need to have those skills for it, and you need to have the skills in the team for it. And that's usually a self-hosted model. And it really comes down to your own appetite, and cost plays a role in that, and skills play a role in that. But these are typically the places where you actually start from, right? So this is all on generative models. Now, let's go to sort of the next piece, right? The next piece is really where where the magic starts, right? Is the generative process starts. Everything before that is just making sure that the model is built. Prompts are where the magic starts to happen and where the engine starts. So what are prompts? How does it work? So prompts fundamentally, and again, since I love talking in analogies, everybody's, if you've written any kind of code, you've learned C and you've learned Java and you love Python. The first thing you write is a hello world problem, right? So you sort of type it up and you say print hello world and you run it and you're extremely excited because you've written your first program. Prompts are that entry vector into using LLMs. It is literally the place where you go in and you can say, write me a poem about interview Kickstarter, and that is as basic a prompt that you can actually sell. It is the equivalent of a hello world program that you write. But there's a lot of magic that happens behind the scenes. And again, in the spirit of what we're doing today, the 100,000-foot view of what the magic that actually happens behind the scenes. You take that prompt, and then you identify, or essentially the LLM has this whole prompt layer, which then identifies things like the task definition. What is it that you're asking me to do? What is the task context, right? Is what is the information that you're giving me? Constraints is what are things I should keep in mind when I'm doing my generation task, right? And finally, do you want me to format it in a particular way, right? So it tries to infer all of these, and all of this information might not be available here. For example, write me a poem about interview Kickstarter. There's no constraints and there's no format, right? So it just says a task definition, which is write me a poem, giving me a context about this thing called interview Kickstart. I don't know what that is, but I'm going to go into my my knowledge library and try to find it. And all of that then gets sent to the model service, generates this beautiful poem, right? So this is sort of from a high level, the process of taking something or an instruction that you're giving the LLM to do, breaking it down. So the LLM or will actually break down, generates things that are out of that instruction, we send it. Few important things to keep. The context length or the allowed context lengths vary depending on the model that you use, right? For example, GPT 3.5 has about 8,000 tokens, right? And I'll come to the concept of tokens in a bit. Which means that you cannot send it unlimited amount of text, and you cannot expect unlimited amount of text back, right? So there is obviously a limit there. So that's where constraints are important. Remember to count your tokens, right? When you're going into production setup, you get billed or the amount of computational power required is directly proportional to the number of tokens. The tokens is really, one token is roughly about 4 characters, or about 3/4 of a word. So the more number of words you put into your prompt, or the more number of words you're expecting back from the model, is actually going to ratchet up your cost. So remember to count your tokens. So in the world of prompts, counting your tokens is an important piece. Specificity is what is going to get you the desired output, right? Because generative models, as I mentioned, are probabilistic in nature, you want to have some level of constraints there to make sure that you're roughly going towards the output that you're looking for. And finally, like I mentioned, constraints are your friends, right? So make sure that you specify constraints, right? I mean, having prompts without constraints, just unless you're building something which you want to stoke creativity, constraints are very, very important in this process. So specifying constraints is very critical. Putting that all together, let's see how a good prompt is structured, right? So again, context about interview Kickstart, I've mentioned some stuff there. So let's break this prompt down a little bit, right? So here we are mentioning the task context, right? So we are saying, this is information about this company called Interview Kickstart, and this is what they offer. Now, what are the constraints here? Use only this context. Do not try and go into your knowledge base and try to figure out more stuff about Interview Kickstart, right? Just use this context. So that is a constraint. And a second constraint we are saying is, do it in 50 words or less, right? So do not go more than that. Use this context, only 50 words, right? So we've specified those contexts. The task definition is to write a poem, And finally, we are saying, I wanted outputted as a JSON, right? So now, the inference engines and the intent engines of these models are extremely powerful, right? So producing something like this in natural language allows it to break these things down very, very beautifully, right? So it understands the context now, understands the constraints, understands the task definition, and finally knows how to output it. And if you're curious, this is what we got out of it, by the way. So very, very interesting. Vast realm, interview kickstarts, art, courses to prepare the impart. Very nice, right? So I'm actually going to use it in some of our ad copies. But in a probabilistic environment, the idea is to sort of constrain the creativity in a way where you can then sort of get as close to possible deterministic outputs as possible. And that's what prompts allow you to do, right? So if you have to think about it in terms of functions, we write all of these different functions in the programming languages that we do. Structuring a prompt is like writing a semantic function. And I love the word semantic. I'll use it a few different times as we talk in this session. This is a way of setting up a semantic function where you can get an output that you desire, right? So it can be reusable. It can be things that you want to get done in a way where you make it easy for the user to actually get the information that they want, but apply the constraints, apply the context very well, and then you usually get outputs that you actually want there. So what are the different kinds of prompts? So zero-shot prompting, you saw an example of, right? Write a poem about interview kickstart, right? So it's you don't really tell anything more than that, and it's up to the model to really figure out what you mean by that. So that is usually zero-shot prompting. End-shot prompting is you sort of give it a few examples, and these models are exceptionally good at learning about them. And obviously, I'm not getting into too much detail here, leaving this here so that you can actually go back and look through some of these things. But end-shot prompting would be, here is a sentence, right? I love the courses in this program that is happy, or I want more things to be taught to me, which may be ask for something, right? So you can tell the model that this is how I want different things to be classified, and then you can give it subsequent sentences or subsequent prompts, and we'll be able to classify them exactly the way you did the earlier one. So this is like you're giving a few examples and then expecting, and then the model learns from that, right? But in our experience of building apps, the first two, zero shot and end shot, are usually not very useful, right? I mean, they're great at, playing around with it, finding the power of these models. Number 3 and number 4, which is where the fancy acronyms come back, is where a significant portion of all the building has happened, or all the advances in the libraries for Gen AI has happened. So chain of thought prompting, which happens a lot with things like autonomous agents, right? You can tell, go and send an email to XYZ person talking about this particular topic, right? And it has to sort of figure out what to do. Is, okay, I need to find information about this topic. I need to find out who this person is, what the email is, and then go ahead and send that email, right? So it's this chain of thought prompting, that step-by-step thinking is what these what these models are getting very good at, right? So that chain of thought prompting is sort of a kind of prompt which is used a lot when you're building agents. And the fourth one, retrieval augmented generation, is what we'll probably talk about, and what we'll probably do our subsequent sessions in the coming weeks with, is how do you give context? How do you give context in a dynamic way, where the prompt then uses that context, then generate more information out of it, right? So that is really what RAG is, or retrieval augmented generation is. And we look at that in a little bit more detail in subsequent sessions. So that is all about prompts. So we talked about the generative models. We talked about the prompts. Let's now talk about vector databases, right? Because I use the word semantic, I like the word semantic, and I think it's cool to use it in different contexts, right? But semantic is essentially the meaning of things, right? So as opposed to syntactic, which semantic is like something, it's like the meaning. So what are vectors, right? And what are embeddings? And it's good to get sort of a sense of those things there. Let's see how we're doing on time. We're doing pretty good. So what are embeddings? So let's take a little sentence here. And again, I'm going to use a lazy developer parlance and sort of do things in a very lazy way because we like to do things quickly. We like fewer lines of code. So a vector is essentially a representation of a text in sort of this array of numbers, right? And in machine learning, this has been done for the longest period of time because it is easier to compare numbers and see how similar two numbers are, or what is the distance between two numbers, right? And it's a very, very common use case for the longest time in things like searches. When you think if you've been around for a while, like I have, all the elastic searches and Lucene and all of those fancy search things that you actually embedded into your products. It's been around for the longest time. Similarity engines and similarity searches have been a much researched project. And the core of it is you take a piece of text and you create a high dimensional or you create a multi-dimensional matrix of numbers, right? Or you create an array of numbers or a vector of numbers. In this case, I use this very cool library from Hugging Face, and Hugging Face is going to be a friend as you go through this process. So it's a very cool library, 3 lines of code, just encode this particular sentence into this vector of numbers, right? So as simple as that. And you can obviously go into much more detail about it, but for the purposes of this, we take something, create an array of numbers out of it. Now, let's say you have a new sentence coming in and you want to see how close it is to an existing sentence, right? So does interview Kickstart offer something for AI, right? And then you go ahead and encode it the same way. And then you find out how similar this particular sentence is to the sentences that you had. So let's again, using Hugging Face, very cool library there, the sentence transformers util. You say for this set of embeddings that I have, right? For this set of vectors of numbers that I have, how close is my new sentence to this list of existing sentences, right? So very interesting, right? When you're thinking about question answers, or when you're thinking about finding similar pieces of text from very large pieces of text, right? So in this case, we use something called cosine similarity. It doesn't matter. There are multiple different algorithms that you can use. But this tells me that this new sentence is about 78% similar to one of the existing sentences I had, right? And that is important information for me to do other things. For example, if I'm running a search or if I'm doing a question and answer, I want to return this answer for this particular question. It allows me all of those things. But this is all simple stuff, right? Relatively simple stuff. Imagine you have to do this over billions and billions of vectors, right? So you have, let's say, everything about Interview Kickstart, which is on the web pages, which is on course material, which is on all of the webinars that we do. You want to take all of that world of text and you want to put it, you want to compute the vectors and you want to put it in, you want to put it somewhere, and you want to enable that ability to search very quickly through it, to be able to calculate these similarity vectors very quickly. That is where vector databases come in. And the concept is very similar to the databases that we are used to, right? The relational databases and the NoSQL database, right? So store something which is very large, be able to search through it quickly, be able to index through it quickly, and that is what vector databases give you, right? So if we look at a typical use case or where a vector database plugs into, again, 100,000 foot of an architecture, right? So I took the retrieval augmented generation, right, which is a typical use case, right? So I have everything about IK. I have this fancy thing telling me that I've embedded everything, put it into my vector database. Now I have my app, where a user is asking me something. It again calculates the embedding, goes and searches through the vector database, gets everything related to everything which is very similar to the question that the user is asking, right? Gets me all the pieces of text there. And then remember this prompt that we talked about? Now we've actually parameterized the prompt, right? So below is the context about Interview Kickstart. You have a parameter there which says context. Using only this context and nothing else, which is your constraint, answer the question, which is your task definition, and then you plug in the question. And then the LLM does what it does, which is the exceptionally beautiful thing of taking all of that context, pulling the relevant pieces of information out of it, and generating a beautiful answer that you can send back to the user, right? So this is a very typical use case of how vector databases plug in. So what do they really do, right? How do they really help? And I gave you a little bit of an example there, but common use cases of vector databases adds memories to your application, right? And what does that really mean? So if you've gone into ChatGPT, you've asked a bunch of questions and you have that conversation history going on, and ChatGPT always seems to remember what you've asked before, right? It always uses that as a context for answering subsequent questions. Behind the scenes, there is a vector database at play because it is using all of that information, storing it there. And as you ask more questions, it is trying to relate those questions to something you've asked before. And that's what semantic memories are. Number two, we just saw it provides rich additional context to your prompts. You can give it, it's like an open book exam, right? So you go into an exam, you say, take your textbook with you, and we're going to ask you semantic questions, right? Like we're not going to ask you questions directly mentioned in the textbook, but semantic questions. And you can open up the textbook and figure out how to answer the question. That's what really context is provides rich additional context to your prompts. We talked about context length, and that is something which I probably skipped over, right? Most of these LLMs have a length, a max number of tokens or a max length of what you can actually put in terms of a prompt and get out of it. GPT 3.5 has I think about 4,000 tokens. GPT 4 has 32,000. Bard has something similar. Claude has something bigger. But adding a vector database, especially if you're using some of the smaller LLMs or the open source LLMs, allows you to increase the context length infinitely, because you can take a piece of that context from the vector, put it into the LLM, get an output, add another piece of context, go back to the LLM, get an output, and keep doing that until you have your desired answer, right? So vector databases actually extend the capability of smaller LLMs by whatever amount you want to, because now you don't have to plug in that and stuff in that entire context in one prompt. And obviously, since it's a database, you get all this cool stuff for free with most of the vector databases. So you get indexing, you get sharding, and you have incredibly fast query engines, right? So that's really the value of it. You have sub-second, and in some cases, double-digit millisecond response times with some of these databases. So what do you have? The world of vector databases started being open source, and obviously Pinecone is the most famous closed source vector database, very heavily used. But these are all your options, and the two surprises there you might see there is Postgres and Redis. Yes, they do allow vector embeddings and search over vectors, right? So good to know that if you already have that in your stack and you want to leverage it, Postgres and Redis are great options. But what should you consider with this, right? So the ease of implementation trumps everything. Speed is critical, right? So you want to be able to build things quickly and get it out, and you want to test it quickly. So anything which has like a rich ecosystem of APIs is always going to be a good idea for you to choose, right? If you're going open source, community is key, and most of these have very, very strong communities. So the ones that I mentioned here, the open source ones, are very, very strong communities. So going open source, community is key. But this whole world of vector databases is going to explode, because as generative AI expands, the use cases and the requirements of vector databases are going to become much, much bigger. So we're going to see more and more players come into this market. Make sure that you measure speed of retrieval, right? You don't want the vector database to be a bottleneck in your app. So make sure that the speed of retrieval is very, very fast. But at the same time, the other side of that coin is speed of retrieval is directly sort of related to how it indexes things. So keep an eye on indexing costs, because indexing is an expensive operation, requires a lot of compute, requires a lot of storage. As and when the data size goes up, your costs tend to go up over a period of time. So these are things to consider, things that do indexing very efficiently. Obviously those are good vector databases, but also make sure that the speed of retrieval is a critical piece that you look at. So anyway, so that was sort of the world, or a very quick overview of the world of vector databases. Let's now come into actually the code aspects of it. So abstractions. I'm a lazy dev. I just want to build things. I don't want all this fancy stuff that's happening behind the scenes. Somebody just write a library and I'll just use it, right? So what are the abstractions available today, right? And what do abstractions give us? So I've shamelessly pulled this from the web, because I think it explains what we want out of an abstraction library, in the world of generative AI, right? So you have an abstraction library, which should give us, if you go all the way from from here, you want it to be able to connect to multiple different models, right? So you want something that can connect with one line of code. You should be able to connect to GPT, OpenAI's models. You should be able to connect to Bard, Claude, all of these different models, right? You should be able to connect to them. Llama, Falcon, all of these, you should be able to connect to them without writing a lot of code. And that is the abstraction you need. Then you need the ability to create reusable pieces of code or reusable semantic pieces of code. So which is what I mentioned about the prompts, right? So if you think about the prompt as being equivalent to a function, you want to be able to make reusable pieces of it. And that's what tools are. Example selectors, again, these are important when you want to use n-short prompting. When you want to give it examples, you need to have a library of examples. Some of these abstractions give you that, some of them don't. But what you need is a very rich prompt interface, right? So you need a very, very rich prompt interface because that is where all the magic is starting with Gen AI. So these give you exceptional abstractions to building prompts. Obviously, the more vector stores that you have abstractions to. So being able to write a couple of lines of code and just being able to connect to any vector store and all the CRUD operations and all of those and the querying operations are all abstracted out for you in very simple ways. That is a very critical aspect of choosing an abstraction library. Document loaders, right? So we talked about everything from IK going into this vector databases, and that could be anything from web pages to PDFs to database dumps to Google Sheets to anything, right? So the ability to be able to use those and actually pull data out of it and put it somewhere, right? And put it in a vector store or use it to train a model. All of those are important. So having these document loaders is important. Output parser is very self-explanatory. What you get out of the model, you need to be able to parse it, render it in interesting ways. And this is where the token concept comes in, right? These text splitters is where, depending on these different models that you use and the kind of token lengths that they support, you should be able to split your inputs in interesting ways to make sure that you're fitting within those contexts, right? So all of these abstractions, right? And this world of abstractions is what these libraries give you. It significantly simplifies your ability to connect to LLMs, to connect to vector stores, to build your data, models, to build your apps, and from there, it allows you to iterate and build your apps in a much quicker way. And who are the players here, right? And we've used both of these, and these are probably the big daddies in this space, right? So LangChain, you must have heard of, has been around for a long time. Started off as an open source project, still is an open source project, but obviously, they've received a lot of funding and they are doing much more now. Very, very rich library, right? So it's been around for a while, so you can obviously see the depth to which, in terms of coverage they have, document loaders, LLMs, the number of vector databases they can integrate with, a lot of abstractions for splitting documents, building reusable components, being able to do that chain of thought prompting, right? There's all of the abstractions for that. So they call them chains. And obviously they have support. Obviously they have support for Python and JavaScript. So you can write your code and integrate LangChain into it as a library in Python, or you can do it in JavaScript. Semantic kernel is Microsoft's contribution to this space, right? So while they're fairly new, so you'll see that some things are actually missing, but it's an exceptionally architected library, built for extensibility. You can add, it is again open source, so you can add a lot of stuff into it that you want to. In fact, you can actually take some libraries from LangChain and plug it into semantic kernel. For example, the document loaders, you don't have it in semantic kernel, you can take it from LangChain and plug it in there and do your document loading there. Obviously, since it's Microsoft, they've sort of optimized for OpenAI, but they do allow you to connect to Hugging Face models. Smaller number of vector stores, but that shouldn't really be a decision point for you. The biggest vector stores are actually integrated by both LangChain and semantic kernel. All of the token splitting, document splitting, all of those libraries, important when you're building your prompts and building contexts for sending instructions to an LLM. Nothing from semantic kernel yet, but it's in the pipeline. But again, like I said, you can take some of these abstractions from LangChain and plug it into semantic kernel. Again, their reusable components, which they call plugins, is beautifully architected, and something which literally with like 2-3 lines of code you can build a plugin, right? And that's something that semantic kernel does really well, much better than LangChain. And the other thing that they do really well is something called planner. So this whole thing of these autonomous agents is how do you do those sequence of steps. LangChain has a pretty good interface, very well documented, but with semantic kernel, it's almost like magic, right? So they inherently connect to a vector database, pull all the chain of thoughts, and are able to sort of figure out what the right sequence of events are in very, very seamless ways, and they print it out beautifully. So I think semantic kernel has done an exceptional job with planners, and they do support C# and Java. So apart from Python, since it's Microsoft, they obviously put in a lot of support for C#. They put in support for Java. So this actually makes it a lot more accessible, especially if you're not used to coding in Python or JavaScript. If you're a C# developer, if you're a Java developer, this makes it much more accessible there. So these are sort of the two big daddies, and you don't need to go very far away from either of these two. Obviously, I've used LangChain quite a bit because it existed for a while, and it was there when I first started with it. Recently started playing around with semantic kernel. But as I use these, I realize that the world of these libraries also actually starts to explode quite quickly. So these are going to go through multiple iterations, and they're going to have newer abstractions built into it and newer capabilities built into it. So choose any one of these, and you will not be disappointed with sort of the ease of use of either of these libraries. There is a third library in this play. It doesn't make a lot of noise, but it's actually the library I use for the first time to build my first apps. It's called Llama Index. It is optimized for retrieval augmented generation, right? So it is optimized for taking in a lot of context, putting it in a vector database, and then being used to query that vector database, get all of that context, stuff it into a prompt, and then get the answers, right? So it's a very, very an exceptionally good library, lightweight library for if you want to build things like chatbots or question answering systems or support agent, things that actually need for something to look or some AI agent to look into existing predefined data, collect all the relevant stuff, and then produce information out of it, right? So optimize for RAG. So if you have a RAG use case, go ahead and use Llama Index. I think it's exceptional. Again, has a lot of abstractions for LLMs, for vector stores. And it actually leverages LangChain for a lot of the things that it does. So in a way, it's almost built as sort of a side project for LangChain, and still leverages a lot of LangChain's capabilities. Obviously, only supports Python today, but you can obviously, if you have other, if you want to get very adventurous, you can sort of build a API layer on top of Llama Index, put it on the machine, and then use anything to hit it with the API. So, but very, very lightweight, very efficient library. And obviously, again, undergoing a lot of changes. And I used version 0.12 of it. It is at 0.29 right now. And just the number of things that are coming into it that allows you to do things very quickly is quite exceptional. So 3 libraries for you to consider: LangChain, semantic kernel, Llama Index. Choosing any of these, depending on your use case, you're not going to be disappointed. A lot of abstractions and a lot of ease of use built into this. All right. So now that we sort of figured out all the different small pieces of components over there, right? So how do you put it all together? And again, in the spirit of what we're talking about, it's the 100,000-foot view, right? So this is what a potential solutions architecture for building a Gen AI app looks like, right? Or at least what it looks like in my head today. And this obviously goes, this changes as well, because as the Gen AI landscape changes. So you'd have an app, you would have an input processing layer, which typically makes sure that, like any other thing that accepts an input, you want to make sure that the input is well formatted. It's not blank spaces. It does not have any explicit content. It is things that you expect to actually get. Make sure that all that input is processed. And then you throw it towards your abstraction library, which significantly allows you to connect to your DB stack, which could be a combination of vector databases, your relational databases, your NoSQL databases, your caches. All of that sort of comes under that abstraction library, allows you to sort of go in and out and pull data and put data into that. And then you have what I call the model zoo, right? And in my head, I don't think there are very few use cases in my head. And again, it might be just how I view this, but the use cases where you just use one model seems very, very limited, right? It's going to be a case of using multiple models. You could use a very small model to do something specific. Then you could use a larger model to do something more rich and diverse. You could use an image model to generate some kind of image outputs. You would want some audio synthesis. You'll have an audio LLM or an audio generative model there. That's your model zoo, right? And your abstraction library is going to enable you to take, for example, something out of your vector DB, throw it at one model, get that output, put it into, let's say, an image generation model, get that output and put it to a video generation model. So you're going to have these model zoos there, and your abstraction library is going to play an important role in sort of making sure that you're able to manage that interaction well. And finally, the boring piece, but a very critical piece, is all of the logging and telemetry, right? So which model is failing, and what is the kind of outputs that are coming? What is the exact prompt that was sent, and how do we audit the generation of these various models, right? So that's going to play a very critical part of when your app starts to scale and when you build these more and more complex apps, right? So that essentially is going to play a critical role, and that's going to form sort of the base of everything that you build. So this is sort of the typical, or in my head, what the typical architecture will be. And there are going to be more components that eventually come into this. The abstraction libraries are going to get richer. Some of the logging and telemetry is going to get rolled into the abstraction libraries. More databases, more models. All of those are going to be important pieces in this architecture. All right. So it looks like we're just about coming up to time, and I wanted to sort of cover the last few things. So we wanted to cover a whole bunch in this session, but obviously, we had to leave something for the future, and some of the things that we left for the future are these, right? The whole fascinating world of MLOps is how do you build the TTDR that I used to call it, right? How do you train? How do you build, train, evaluate, deploy, and keep repeating that process, right? How do you monitor, keep repeating that process? The whole area of MLOps, which is critical, especially when you're thinking of production systems, right? Model fine-tuning. It's starting to get a lot of traction now, especially with the open source models that are there, and the models becoming smaller and smaller, right? So you can, obviously the richer models need these massive CPUs with a lot of memory to be able to do your training. But now models are becoming smaller because you want specific use cases. A great example is you want a model to teach you high school math. You don't particularly care if it knows the capital of Nebraska, right? So you would have a smaller model and train it with very specific context. Using notebooks, a lot of you might have already used it, but it's worth sort of exploring. Jupyter, Google Colab, use it. They are your best friends when you want to prototype and test quickly. I mean, that's how I got started before I even went into PyCharm and wrote any code to actually build my apps. Jupyter and Colab are the places where you can prototype and test quickly. The whole world of logging and telemetry, what do you want to log? What are the things you want to monitor? How do you test performance? How do you figure out what kind of prompts are going in? How do you calculate tokens? All of that stuff is something that we want to cover in future sessions. And Hugging Face, right? So Hugging Face gives you an exceptional hub for any kind of model that you need, right? So obviously you have all of the open source models like Llama and Falcon, all of those hosted there, but you also have incredible models for summarization, for generating text to audio, text to speech, all of those very, very cool models there. But what is lesser known about Hugging Face is they also give you an exceptionally rich library in Python, but exceptionally rich library for you to do a lot of things. I showed you a little snippet of it when I did my vector encodings and then I did my cosine similarities, but they give you a very, very rich library that allows you to do a whole bunch of things in machine learning. So those are things that we want to cover in future sessions. And I wanted to leave you, the last thing I wanted to leave you with before I open it up for questions, it's some of the tools that we've been impressed with. And I would love to have an opportunity at some point to show you some of these tools and talk about it, right? So obviously GPT-4, a lot of you might have been exposed to it, but if you haven't, it is available through its API and it is available on the ChatGPT Plus subscription. It is worth it, right? It is absolutely worth it. You have GPT 3.5. It's great, which is the free version of GPT that you can log into OpenAI and play with. But GPT-4 is exceptionally rich with its depth and clarity, right? So definitely play around with it. Synthesia for video, 11 Labs for audio. Definitely use these. They have free tiers, so you can actually play around with these. I use UiZart for design. It's a design tool, just like Figma, but has some exceptional generative AI capabilities. You give it a prompt and it comes up with a design of a whole app, right? So it's brilliant. GitHub Copilot. Some of you might have used this, and there are a whole bunch of code copilots at this point. But GitHub is just exceptionally fast, right? And it has exceptional context of what you're actually doing. Is able to complete code snippets very, very well. And Jasper has been around for a long time, right? So in terms of content generation, just the level of depth it has in terms of taking something which is like a very narrow idea and then being able to expand that out. Jasper is quite exceptional there. And things, we'll probably cover in future sessions. So that brings us to the end of the first part of the series, which is the lay of the land. Q&A. Feel free to put your questions on the Q&A tab. I think we have a few minutes. We can spend about 5 minutes. I can take some questions here, and feel free to ask me questions about anything. It doesn't have to be about this presentation. It could be about anything else. We also have our exceptional founders, Ryan and Soham here. So if there are questions I cannot answer, they'll be happy to take it with you. Let me go through the questions here. Somebody said, can you please go back to the previous slide with all the models? I will come to that. Maybe I can just quickly do that right now. Let me go back up. Yeah, there you go. So I'm going to keep that open while I take the next question. So great question. Prompt engineering, or Gen AI, as I understand it now, is LLMs and models are already out there to be consumed through APIs. We need to try and improve prompts to get it to a desired answer and show in some intuitive UI and apps, right? Which is a pretty good summary of sort of building a Gen AI app. The question is, what would be the role of data scientists in the future as LLMs are abstracted and cannot be trained? Okay. Prompt engineering, or Gen AI, which is the current and will be the future trend, seems like it just requires good engineers to design prompts and handle API responses. It doesn't need any prior learning of AI ML concepts. So great questions. So let me take your first question, right? What would be the role of data scientists in the future as the LLMs are abstracted and cannot be trained? So I would like to challenge you on that point, right? So data scientists are going to be very critical to any kind of AI development and any kind of AI, any kind of AI innovation that happens down the line, because LLMs constantly need to evolve, and the evolution of LLMs happens where it starts from the data, right? I mean, models are essentially garbage in, garbage out in many ways, right? So the garbage in is the most critical aspect of when you want to make sure that the garbage out is something that is usable, right? So the role of data scientists is going to be very, very critical in that aspect, right? So all of the data that gets collected, all of the all of the massaging, all of the cleaning, all of the labeling, the patterns, those don't happen by magic, right? They happen through algorithms that the data scientists use. They happen through clustering algorithms. They happen through regression algorithms. I mean, those are things that you need to do before you can actually start the model training process by itself. So data scientists are going to play a very, very key role as this whole ecosystem evolves. So there is never going to be a place. So LLMs being abstracted is more on the ease of use of doing a lot of things, right? Is how do you make sure that you abstract the fine tuning of it? How do you make sure that you abstract the generation part of it? How do you abstract the prompts part of it, right? So those are the place where the abstractions will come, but the fundamental process of building and training and deploying models still requires a key role of data in that entire place. So data scientists are not going anywhere. Their role is actually probably going to expand a lot more in the future as this space increases. The second thing that you asked me is, it seems like it just requires good engineers to design prompts and handle API responses. Doesn't need any prior learning. So building of solutions, generative AI app solutions, does not require you to need to know AI ML concepts. It does not. But knowing how these tools work, and it is like any other tool, right? It is like any other library that you use, right? Understanding how it works and understanding its capabilities, understanding its pitfalls, understanding what it is not good at, right? And why it is not good at, obviously makes you a better engineer, right? Makes you a better solutions developer or makes you a better app developer, right? So it is important to, you can get away with just designing prompts and just handling API responses and throwing it at a UI and be done with it. But that is just, just building apps, right? When you want to make it a production grade system, a lot more goes into the understanding of, okay, why is this LLM slower than this one, or why is this prompt better than this one, or why is this particular abstraction needed, or why is this particular vector database is needed, and why is the indexing fast over here? How can I tweak the indexing to make it go much quicker? How can I deploy an LLM that can do limited tokens but very high precision, right? So those are some of the things that when you get to production level systems or production grade systems, those are things that are going to be very, very critical for you to understand. And that really separates, what in my head are developers from engineers, right? Is getting into the depth and getting into the internals and understanding how things works just makes you develop better solutions. So yes, you don't need to learn AI ML concepts, but knowing them just makes you much better at developing these solutions. All right, Vikash has a question. My model zoo, by model zoo, do you mean that a single app is going to leverage multiple models? That's right. That's right. So think of it as a way of sometimes apps have different databases, right? In some ways, and today you have you could be you could have an app that has multiple different use cases, right? So you could have an app that generates some kind of explanation to a concept, right? And I say it from an interview kickstart lens, right? So you could have a language model that explains a decision tree to you, right? And then you want to take that explanation and generate, let's say, an audio piece out of it, right? In my voice, maybe. Then you would use you'd use a speech model or an audio model, which will actually generate audio out of it and make it sound realistic and live. Or you want to do a video, and you want to make sure that video looks like me, and that could be something that uses a video model that then generates the audio and then generates the video and creates something that becomes something that you can see and hear. Or it could be that I want to generate a piece of content which then has an image of what a decision tree looks like, and just so that people can visualize it. So instead of creating all the diagrams that I did on this slide, there's this model that just spits out that image, creates that content, and now you have a language model, and then you have an image model that then combines the two, right? So there are a lot of different use cases that are going to come out as we build more and more complex apps. And it's not going to be just one model that does it all. It's very hard for one model to do it all, right? Even these list of models, these do different things well, or these do specific things well, right? So you can't have a one model that rules them all. And that's sort of how I see this landscape or this environment evolving there. Great question, by the way. There's another question here. How can we use these models? Do we need GPU? Is there a cheap option for students? The cheap option for students is Hugging Face. Your models are hosted. So a lot of the open source, in fact, all of the open source models are hosted on Hugging Face. Hugging Face exposes, an API, which doesn't cost a lot if you want to use it. In fact, they have a very generous free credits tier. And if you're a student, I think they give you a much more generous free credits tier. And if you're in a university, some of these universities have an agreement with Hugging Face. But Hugging Face is the place. They have their own stack of GPUs. All these models are hosted there, so you can actually go in, fine tune them, play with them, use their inference APIs. Most of it should be covered for the kind of use cases you have. Most of these would be would be covered there. I do see a response there from Nitin saying you're able to use Llama 2 to run some models on your 6-year-old Linux computer. Yes, I mean, models are getting smaller, right? I mean, there is this company called Illuthor, which produces really, really tiny models, like 70 million parameter models. that I've actually put on my laptop. My laptop has, it's a fairly old laptop. It's about 5 or 6 years old, and I was able to actually train a model. It didn't, it wasn't very powerful, but it allowed me to get a sense of how that fine tuning process works, right? So yes, models are getting smaller. You obviously have these massive models, but then like everything else in tech, the power stays and the size becomes smaller, right? So essentially the use case would be, how do we fit a model into your smartphone? And that is going to be the use case that everybody wants to drive towards, because they want to bring that power of language models and generative AI to your phones, right? So making it smaller is going to be an active work that's going to happen from all of these different companies. Somebody's asking, how can we join the next 2 sessions? Look out for an email from us, right? So we'll send you an email about this, and you can actually sign up for these sessions. Do attend the next 2 sessions. I'm very excited about it. I mean, it's my chance of sort of showing you what we've done and how we've gone about doing it. So definitely join those 2 sessions there. Some other follow-up questions here. Can you provide more examples of how vector stores work? It seems like they retrieve the stored context based on input context. Is that correct? It's sort of a roughly right, but there is a lot of nuance to it. Yes, there is an input that goes, and it's like searching. It's like doing a query, right? On databases, right? So you construct a query. You sort of go, you sort of send it to the database. The database has its query engine that then parses all of the things, like it parses it in the prompt, and then it uses the indexes and it uses the tables to actually figure out the data. Vector databases are similar, right? And just in this case, they're actually searching on it. It's much more unidimensional in the sense that it just stores a whole bunch of arrays of numbers, and then searching across that space becomes very, very fast. So they're fundamentally simpler in their architectures than relational databases or NoSQL databases are. But very, very powerful in a generative AI context. But yeah, you have the rough idea of what these are. All right, in the interest of time, I'm actually going to take another couple of questions, and then we'll sort of close it for today. So Sri Lakshmi asks, in the next few years, which job, and I'm just paraphrasing what you've written, which job has more demand? Would it be ML engineers or data scientists? I wouldn't look at it that way, Sri Lakshmi. Both of these roles are actually going to be in extremely high demand, but and so are a lot of sort of the traditional roles, right? The back end, front end, full stack. All of these are going to be also in demand. The way to think about it is that all of these roles, right? Everything from, if you take away ML engineers and data scientists, which is your question, but all of the other roles, right? Which is your back end, front end, full stack, PPM, product managers, is going to need some understanding of AI and some use of AI, some use of sort of tools that use AI. So that's where your understanding or your use or your exploration of generative AI is important, because it is going to fundamentally impact every single role that is out there. So if you're looking, if the context of your question is what is a good career option for me, regardless of what you choose, getting yourself into what generative AI offers and kind of what it allows you to do is very, very important, right? But to your question specifically, ML engineers or data scientists, well, both of them are going to be in pretty high demand. If you look at the jobs report of the US, you're going to see that it's one of the fastest. These two are some of the fastest growing job roles or job openings that are out there in the US for different companies. So yeah, both ML engineers, data scientists, data science, ML, both of these are going to be extremely high demand. But that does not mean that some of the other roles are going away. Other roles are going to be in high demand. But the expectation is that you understand how this ecosystem works and how the space works, because a lot of what you do is going to be directly impacted by all the advances that are happening here. All right, folks, I'll take one last question. So Jagdish, very interesting question, right? To consume these models, when it integrates with open source models, should we be planning for versionalized use of these models in the context of, say, fintech industries, in the light of chain of thought prompts or RAG? Should the app be hosted on Cloud VM or other fancy hosting infrastructure, or does it suffice with home office equipment? So let me break that down, right? So you're obviously asking if I can take an open source model and train it in some way with my own data, and where should I be hosting it, right? Because obviously when you say fintech, there's the concept of security and domain specificity. That's all important there, right? So yes, you can host it on your own infra, right? So and home office equipment, well, if you have sufficiently powerful home office equipment, then you can do it there. But I wouldn't recommend it. Hosting it on the existing cloud providers is probably the way to go. They have solved a lot of the security issues. They've solved a lot of sort of how to make sure that you have your own private space there. It does work out to be cheaper in the long term. You don't save a lot of money by putting it on home office equipment. So definitely host it there. But as the space keeps going on, right, as these models evolve and more use cases come out for different kinds of models, my sense is that you will have these massively large models like GPT-4, right, which has been trained on like some 300, some multiple 100 trillion parameters. And you'll have these really tiny models which do one thing really well, right? Which is, for example, from a fintech space, it could be just, it could drive some kind of analysis of let's say, stock histories of the last 100 years or whatever, right? So it could be very, very specific and does not have a lot of exceptional language generation capabilities or image generation capabilities, but does one thing really well. It does analysis really well, right? So you're going to have those two different use cases. And really, in the end, it comes down to the things that I mentioned here, right? Is what are the things that you really care about? What is your use case? And what are your constraints, right? Is cost your constraint? Is security your constraint? Or is really having the skills in your team your constraint? And that really sort of drives your decision there, right? So, and when you talk about chain of thought prompting and retrieval augmented generation, all of these things are now built. All of the cloud providers, Amazon, Google, Microsoft Azure, all of these are rapidly creating sort of these environments or these stacks, right? These stacks that allow you to quickly spin up instances, get things going, put data in there, and then sort of start building your apps, right? So they're literally enabling you to do this much faster. So absolutely consider, unless you have very strong reservations on putting something on a cloud VM, I would say that is the way to go, because that just cuts down on a lot of the maintenance, and that cuts down on a lot of the monitoring that you have to do, because all of these you get out of the box with these cloud VMs. It allows you to focus on just solving the problem that you're trying to solve, right? And that is really what the subliminal message here is, right? Is focus on the problem that you want to solve, and let sort of all of these abstractions and let sort of all of these providers sort of help you become much more powerful there, right? Become much more productive there. So that is really the way to think about it. All right. So I think, and there are a lot more questions here. I apologize, I can't take all of them at this point. Thank you all so much for joining this session. It is a lot of fun for me to do this session, and I'm really looking forward to the next two sessions that we have. Definitely join in for those. And all of you have a great evening. I hope you get to start exploring. I hope this has whetted your appetite and you get to start exploring this a little bit more. Have a good evening, everyone.